Hey everyone, on this lesson we will continue with the dimensionality reduction project applying the principal component analysis. So on the previous lesson we introduced this data set, we created a notebook in Google Colab, we did the initial study of this data set, right? We loaded this data set, we also transformed the name of the columns, we mapped the different values for the species and for the sex attributes. And we also saw that we needed to separate the 200 grams that we have in total into 4 classes, right? So we created here a new column in the data set. The name was class. And here, this was the concatenation of the species of this crab with the sex of this crab. So now at the end, if we check now the new data set, we have here an extra column for the class, right? We also saw the tail and the head of this data set. So remember, when we write the head method in a pandas data frame, this will return the first 5 rows, the first 5 instances, and we have here that the class is again the concatenation of the species and the sex. For instance, the crab 2 is blue and male, so we have here that he belongs to the class blue male, and so on. So on this lesson, we will do a first initial visualization of the classes on this data set. So we will here solve this first point of the project. And on the following lesson, we will improve this visualization applying the principal component analysis technique. So here, let's continue and add a new text window. We will start with the basic exploration of the data set, right? This visualization. Now, since on this data set, the only features and measurements that are important and relevant are these ones, right? Here, the sex, the species, or the index is not important. So we will explore this continuous values of the frontal lobe, the rear width, the carapace midline, the maximum width, and the body depth. So we will define now a variable data columns that we will store the name of the columns that are relevant for the initial study. As we have just mentioned, it is going to be these columns. We can transcribe all the statistics information about this column. So here on the Krebs data, we can access these columns, data columns. And here we use the describe method in pandas, right? With this, we only describe these columns. And here, keep in mind, we need to change this width. This W is in uppercase, right? This is in uppercase, so we change this to be in uppercase. We run again. And now we see the description of only these columns that we have specified. We have a total number of 2, in this case 200 instances for the frontal lobe, and the same for the rest. Okay, all the attributes are defined. The mean of all the values of this frontal lobe here, we can see it is 15.58, right? The mean for the rear width is 12.73, and so on. Here it is the standard deviation, the minimum value, okay? The minimum value for the frontal lobe is this one, and the same we have for the rest. And here we can also see the percentiles, and finally the maximum value of them. So here the crab inside this data set that has the maximum carapace midline is this value here with a value of 47.6. Right, so this first point of the project asks us to do a visualization. Here we are only doing a statistic description. So let's start with the visualization of the classes. So before going into the classes that are basically blue male, blue female, orange male, orange female, we'll first visualize the data set with the relevant columns, and then we will visualize the classes. And we will also discuss why we need here, and we have the necessity of applying a dimensionality reduction technique such as the PCA. Okay, we will see why this is important. So we will start with the box plot. Here on the text, let's just visualize this with the box plot. So box plot of the relevant features And now to represent this box plot, we will need to use the matplotlib library for Python. And this is a very important plotting library for creating static, animated, and interactive visualizations in Python. So we need to import this library. We go here to the section on imports. Okay, we can also do it on that last cell, but we will do it here on the first cell of code, right? So here we are going to import the matplotlib library. To do this, we just use here import matplotlib .pyplot, like so, okay? And now, as we can see, we need to add here as PLT. With this, we will import the pyplot for the matplotlib library. This is the pyplot object-oriented that will provide the applications and the visualizations that we want. So we run again this cell. Do not forget to run again your cell. So now your Colab notebook is updated, right? And now here, we will use a box plot, right? So first of all, we will create a new figure, okay, and new axis also, and we can create this in the object-oriented style of pyplot. We just write here pyplot. Remember that pyplot was imported as PLT. Whenever you want to use the pyplot, you just write PLT. So here we use pyplot. To create a new figure and axis, we write the subplots method. And here we can also specify the size of this figure. We will specify a size of width 8, for instance, and height 5, right? So once we have this figure, in fact, if we run this cell like so, we'll have an empty figure. So we want to draw the box plot of the relevant columns that we see here on this data set. So to do this, we need to first write the name of the data set. We want to also access the columns, okay, the specified columns that we want. So we want only the relevant columns. This is the data columns variable, right, like so. And here we just do a box plot of pandas, like so. Okay, so now when we run this, let's run it. Here we can see the box plot represented of all these variables, all these features: the frontal lobe, the real width, the curve base midline, the maximum width, and the body depth, represented in a box plot. Remember that in the box plot we have the information of the minimum, the first quartile, the median, the third quartile, and the maximum of the data. Remember that we can interpret the box plot in this way. This is not something and concept that belongs to the section of this PCA technique, but it's very important to remember. Okay, if we have a box plot, we can have here the upper whisker. If we have data that goes above the upper whisker, then they will be possible outliers. This upper quartile is the third quartile. Then this horizontal line is the median. Here we have the lower quartile, also named as the first quartile. And finally, we have here the lower whisker, that if we have data that goes below this lower whisker, they will be possible outliers. Again, this is not something that we will go inside and study deeply, because this is not a statistical course. However, this is only a visualization process that we will do initially. So then we have this information visualized about the columns, right? So now let's proceed with visualizing the classes of this dataset. Remember, we have 4 different classes, right? If we see here, we have the class blue male, blue female, orange male, and orange female. So now on this visualization of the classes, and this is what it is very interesting, we can study these features, these attributes, separately, depending on the given class. So let's see how we can do this. For instance, let's suppose we want to study the frontal lobe depending on these 4 classes. So we want to see how it is different when some crab is a blue male, some crab is a blue female, orange male, or orange female, how the frontal lobe changes. So here let's add a new text window just here below. Okay, we can just press this cell new text window, and here we can say that this is the initial visualization of classes. So let's start with the frontal lobe feature. This is a relevant attribute, and we want to study the classes with this attribute. So to do so, we just access the name of this dataset, which is Colab's data. We will represent a box plot. So again, we write the box plot method in pandas data frame. So this is a box plot. But also here, moreover, we will specify the column name. So the column name, as we can see here, is frontal lobe. So frontal lobe. And now how we set the classes to be studied? Well, we can do this with an extra argument in the box plot method, that this is the by argument that we can set where we want to study. So we want to study the classes. So here by class, right? So remember that this attribute here that we created extra is a class, this new feature. If you have written another name, then you just write this new attribute name that you have set. For our case, we have set class, so here we just write class. And again, we will specify the figure size to be the same, which is 8 and 5, right? So here 8 and 5, like so. Very well, so now let's run this cell. And as we can see, now we have 4 different box plots depending on the class. And the feature that we are studying is the frontal lobe, as we can see. Here we have the class blue female. As we can see, a blue female has, in general, a smaller value of the frontal lobe than a blue male, right? Their values is bigger. And here, on the other hand, on the female species, it can easily be seen that an orange female has in average, greater value for the frontal lobe than an orange male. Remember that here it is the frontal lobe attribute that represents the frontal lobe width of the graph. So this is very interesting because we can see how different classes behave, okay, and extract conclusion depending on the classes. So we will do the same thing for the rest of the relevant features, okay. We have a total number of 5 relevant features, so we did it with the frontal lobe. We'll do the same with the rear width and so on. So here we can just copy this cell, we can add a new code, and now we can change this name to be the rear width. We run again. We can also see here how the rear width is different depending on the class. We add a new window of code, and now we just change this to be the carapace midline. So now we are going to study the carapace midline. We run this cell. We see also this variation. Now we do the same for the maximum width and the body depth. So here we create a new code window. Now for the maximum width, we can see now the box plots depending on the class. And now finally, to end this visualization with the box plot, we add now the box plots for the column body depth depending on the class. So we run this cell, and as we can see, we have these 4 block spots. So with this, we are visualizing the 4 classes of the data set with box plots. We can also do histograms and represent histograms, where the hue of the histogram is going to be the class. So initially we can just plot histograms. So we can add here new code window and also text window before to represent that we are going to do now histograms study. Very well. So before going into the classes, in the same way that initially when we were working with the box plots, we plotted, right, the box plots of all the relevant features, we will also see here the histogram of all the relevant features. So let's come here to this new window. Here we will access the Colab's data set, right? The columns that are relevant are the variable data columns. Here we have all the relevant features. Now we will use here a histogram, and to do this, we just write the histogram method, which is the hist. This syntax will create a histogram. The size of this histogram, let's just say it is 16 width and 4 of height. And also the layout, let's say to be a layout of 1.6. So here the layout is 1.6. remember that this layout is nothing more than the tuple of rows and columns for the histogram, right? We can even comment this, but it is important to remember that the layout here, layout, is this tuple of rows column for the histogram. So the idea is, how many histograms will we have? Well, we will have a total value of 5 total important features, right? They are these ones, as we can see here, the frontal lobe, the rear width, and so on. However, we are going to add an extra layout here, an extra column, so we have more space. But you can also change this to be 5 and it will also work. But we are going to add an extra column in blank to have an extra space. So now let's run it. And as we can see, we see these 5 histograms, and we also see an extra space at the end because of this 6, right? And we have here all the important features. So now let's use this histogram visualization depending on the class, since this first point we need to visualize the classes. In order to do so, we will create now a new code window in here. We'll pick, for instance, this first feature in order. Let's do this in order from left to right. We will now study the frontal lobe depending on the class. So the first thing is creating a new figure. Remember that we can do this with the pyplot figure, right? Now the name of this figure, it is not important because we are not going to title this figure. We are only going to visualize. And now let's specify the size of this figure, for instance, to be 8 width and 6 height. This is a sufficient size. So now to plot the histogram depending on a given value, depending on a given class, right, which is going to be the hue. Now the class, let's visualize now this last attribute. This class feature is going to be the hue for this frontal lobe. So to do this, we need to use a histogram plotting from the library of Seaborn. Seaborn is a Python data visualization library based on Matplotlib. So it provides also a high-level interface for drawing advanced plotting. So again, let's go to the initial window of imports, and now we are going to import the Seaborn library. To do so, we can simply write import Seaborn as SNS. We run again this cell, we update the Colab notebook. Right now the Colab notebook is up to date. And now on this new figure that we are going to plot, we are going to plot a histogram plot using the Seaborn library. So to do so, we need to write here the Seaborn, so SNS. We will use the method isTplot. This is for histogram plotting. Now the first argument is the data we want to plot. So the data set is grabs data. The second is if we want to specify a given column. Keep in mind that what is the column that we will start the first? Well, the first column is going to be the frontal lobe. So here we specified with the X value. This X value specifies the column that we want to study. So in this case, the frontal lobe, like so. And now finally, a very important argument of this method is that we can set the hue. So we will study depending on a given value of the class. So here the hue is going to be the class. Finally, we can specify also the number of bins of this histogram. A value of 20 will be sufficient. Very well, so now let's see this visualization of this histogram depending on the class. So let's run this. And as we can see, here we have the frontal lobe histogram depending on the class. And this is a very important visualization. We can see that the class in blue is for the blue male, the class in orange is for the blue female crab, the class in green is for the orange male, the class in this pink or red is this orange female. Remember that in a histogram we have that for a given value of a given feature, how many instances of the dataset satisfy this value. So for instance, doing one example of interpretation of this histogram, we can say that for instance for a frontal lobe value of 9, okay, which is this case here, we have a total of 4 crabs that are blue female that have a frontal lobe of 9, and only we have 2 crabs, 2 instances of crabs that are blue male that have a frontal lobe of 9. Okay, as we can see on this point and on this point for the class of blue female and the class blue male. In the same way, there are a total value of, for instance, 4 instances of crabs that are orange male that have a frontal lobe of 21.5, okay, moreover, and only 2 instances of crabs that are for this other class in here. The most important here, the interpretation that one can say, for instance, could be this one, where we see that for a given value of 18.5 of the frontal lobe, only 1 instance of crab blue male has this value, right? Only 5 instances for the crabs for orange male have this value of 18.5, and a total of 8 total crabs that are orange female have a frontal lobe of 18.5, right? So as we can see, this is the histogram plot depending on the class, since here the hue is the class. So we will do the same thing for the rest of the attributes. So we can just copy this, so we can create a new code window, right? And now instead of frontal lobe, we will just set here that we will study the rear width depending on the class. So again, we can just plot this and we see this histogram depending on these 4 classes. The same for the carapace midline. We create a new code window now for the carapace midline. Remember that you can download all this code and all this notebook on the downloadable documents of this lesson. Here we see now the histogram. The same we do for the maximum width. So we create this window for the maximum width. And now we see here now the maximum width histogram depending on the 4 classes. And finally we study the body depth depending on the 4 classes. So we create the final code window for the histogram, we run this, and now we see this histogram plot, right? So we did now the visualization of the classes with box plots, with histogram plots, right? And now also we will use here the final plot, which is a pair plot. And also now we will discuss why we need here to apply a principal component analysis technique and why it is useful. So as we've said, we are going to use now pair plot. This we will do it with Seaborn. The Seaborn pair plot allows us to plot pairwise relationships between variables within a dataset. This creates a nice visualization and helps us understand the data by summarizing a large amount of data in a single figure. And also this is essential when we are exploring the dataset and trying to become familiar with it. So it is an essential to enhance your data understanding. And also at the end now we will discuss why it is important to apply here the PCA. First, let's here plot the pair plot. So to do this, we just write here the Seaborn library. The method name is pair plot, like so. Here we write the data set, in our case crabs data, and also the hue. Keep in mind that we want to study depending on the classes. We want to do a visualization, right? This visualization depending on the classes. So now the hue is going to be equal to the class. So let's run this cell and see what we have. So we can see here different colors, right, of these points. They are these 4 different colors, and they are precisely these 4 classes. In fact, if we see here, we have that the blue class is the blue male class, this orange is the blue female, this green is for the orange male, and this red point is for the orange female. So with this we can visualize how the different classes change with the relation of these variables. This, for instance, first example we see here represents how the index changes of the 4 classes when we increment the frontal lobe, right? So as we move to the right, it means that we are incrementing the frontal lobe value, and as we go up, it means that we are incrementing the index. So the index here is not an important feature, so we will skip this first row. However, let's come here to the frontal lobe, okay? And since this column is also for the index, we will come to the second and not only the second because it is only the frontal lobe as well, but now the third column. So keep in mind that this plot that we see in here, this one, okay, this third plot, represents how the frontal lobe changes when we increment or decrement the rear width, right? So as we can see, we have it is easy to see that we have a quasi-linear function with a positive slope. This means that when we increment this rear width, we also see that the frontal lobe is incremented. More is pronounced this slope, okay? This slope here on the next figure, this one in here, is very pronunciated. It means that as we increment, let's see what attribute it's, the carapace midline, okay, the frontal lobe is incremented a lot depending on all the classes, right? So here we can see how different classes change depending on the relationship. So this pair plot is a very important plot when we are studying classes because we can see the relationship between variables depending on classes, right? For instance, let's just study this example. This example in this figure studies how the rear width, okay, changes when we increment the carapace midline. So for instance, for the class in red, which is the class orange female, we can see that we have a slope, okay, very big slope that is greater, for instance, than the slope in green, which is for the orange male. So we can see the relationship is stronger on the class of orange female. This means that when we increment the carapace midline, when the carapace midline is incremented, the rear width is more incremented in the orange female than in the orange male. Okay, a crab that belongs to the class orange female, when it has a very big and a very great value of the carapace midline, he will be, or in this case, she will be likely to have a very also great rear width, right? However, in the orange male, this slope is also positive, okay? The relationship is positive, but it is not as strong, so it is a weaker one, okay? The relation is stronger, and in fact strongest, in the orange female, and also we can see here in orange, okay, more or less the same for the blue female. So it seems to be that female crabs tend to have a very stronger and strongest relationship between the carapace midline and the rear width. Very well, so of course we can do this for all the possible plots that we see this on these pair plots, and we can do it one by one and extract conclusions. However, we have lots of plots because we have too many features, right? So that's why we will apply the principal component analysis, and this is why and where the PCA technique comes on, right? We will improve this visualization using the PCA technique. So let's give here a final discussion. So we add here title, let's just write here discussion for using PCA. First of all, that the high dimensionality makes it difficult and also longer to manage and understand it, and that dimensionality reduction methods allows first to reduce unnecessary dimensions or noise. Also, it will reduce the computational cost when we are doing a learning model in machine learning, and also it allows us to visualize the data in 2 dimensions and 3 dimensions. And this is what we will do on the following lesson when we'll apply this principal component analysis technique. So as we can see, we've done already 2 lessons on this project, and we have not reached yet to apply this principal component analysis technique. But the reason it is that it is more important to know why we need to apply this technique, how this technique will be applied, than just apply it. Okay, we need to first understand why it is necessary. So that's what we did on these 2 lessons. We introduced the data set, we did an initial visualization, and here we can discuss why we need to apply this dimensionality reduction. If we here apply the pair plot for the data set, we have too many plots to study. Okay, just imagine if you had, instead of this 4 or 5 or 6 or any order until 10 columns, imagine if you have 800 attributes. Okay, imagine reading a pair plot with 100 features. So that's why we need to use the PCA technique, and this is what we will do on the following lesson. So remember that you can download all this code and all this notebook that we have done until this moment on the downloadable documents of this lesson.